because on this we know that we can run Snapcraft. And I hope that when I hope that you have also downloaded the slides. And when you go forward to set up, it is here, set up, then you see instructions how you install Snapcraft on Ubuntu, and also some other stuff which is useful for the workshop. Now, you will find, when you go a little bit forward, these instructions. Who did not follow them yet, please follow them. And I hope very much that you do not need to go more forward in setup, where I'm describing how to download and install a virtual machine, which we have, usually for those with older Ubuntu or with non-Ubuntu distribution. But as we are on the engineering sprint of Canonical, I assume that everyone has Ubuntu. And also, if you would now on our conference network download 6 GB, it's also not the best thing with so many people here. We are many people because on the last conference in India, I had 12, and on Guadec, they are really bad. No one came to my workshop. So let us start. We have a workshop on the engineering sprint. I must disappoint you a little bit. We don't have a workshop about diataxis, about documentation. Daniele Procida is organizing a conference in Africa, but to keep you entertained on the engineering sprint, I jumped in and will teach you how to snap. So your application everywhere, just in a snap. This workshop was for the first time given on the Ubuntu Summit 2022, exactly 1 year ago. There it was given by Heather Ellsworth and by Lucy Llewellyn, and they created a great workshop. I use the same materials, I've improved them, I fixed some bugs in them. And so thank you to the two, they have done great work in the beginning. And so as I already told, download the slides so that you can copy and paste for the exercises, so that during the exercises you can also browse forth and back, so that you can look after things which I've shortly shown, or you browse completely to the end, and there are some advanced topics which could be also very helpful. So now what you will learn here is what the hell are snaps and why package as a snap, and also how to package the GNOME applications as snaps. One calls packaging as a snap, one calls also snapping applications. And therefore also the original title of this workshop, when it was given by Heather Ellsworth, who has the username Hellsworth, it was snapping like hell, and then with a parenthesis, snapping like Hellsworth. So you learn also building your applications from source or from binaries. So for open source and closed source, it can be used. Also for quick and dirty snapping from Debian packages. Then to find dependencies, you're also using an auxiliary snap with all GNOME libraries in it to save storage, because snaps bring always their libraries and dependencies, and with the desktop applications, it is a huge waste of storage, and we solve it this way. And what you need to know is basic installing from source and from classic packages. You need to know a little. You need to know also little code tweaks to fix something, which is something usual, for example, when one is packaging something, and also shell scripting, because we embed some shell scripts to control the build of a snap. So, and why do I organize snap workshop series. I've organized a complete Snap workshop series in the Ubuntu Summit 2022, and I organize different Snap workshops. I give these workshops on different conferences, and this is so that many people learn how Snap works, how one snaps packages, that upstream maintainers snap their stuff so that users can easily access it. And you know that we will soon have Ubuntu Core Desktop, where one can install applications only as Snap. So we need everything as Snap, as nicely maintained snaps. And also to make people aware of Snap and how well it works, so that they lose their fear of that Snap is not the right thing. And also, we also are looking for volunteers. Many upstream projects, they are not snapping their stuff. And so we also want to have snaps from them. So there's an organization called Snapcrafters. And this organization is snapping upstream project, which upstream is not snapping by themselves. And many upstreams, they overtake their snaps and continue maintaining by themselves, and other not. But by Snapcrafters, we have many more snaps. And even if you independently snap things and download and upload them to the Snap Store as yourself, we always appreciate this. And at first, the setup, I already told you, download the slides, go to these instructions, and install Snapcraft, so that you can do the following exercises. Can everyone raise their hands who has already done it? There are some. So some people have already seen some announcement by me on MetaMost, where I told, or I have met them personally, and where I have told that you have to that you have to download the slides and follow the setup section. So you have the slides, so I can go on. This one, I hope no one will need on a canonical engineering sprint. So at first I give a small introduction into Snap, because I don't know in which teams you are. And as I see, most people I do not really know. Most people are not in the desktop team. And so perhaps there are one or another who does not really know what's actually Snap is. We are in the world of sandbox packaging. When you are a developer of an application, you probably already thought how it gets distributed to end users. You have an open source application, and you are at least publishing the source code, as you are required to do so. Otherwise, the application can never be open source or free software. And then you think about how does it get distributed, and then this is the step that where potential users of Linux and free software can be turned away. Look at the source code, and most people know what to do with source code. And so only tech-savvy users can directly install from source. Or for the other users, you usually need the goodwill of distribution maintainers, like we here at OpenPrint, we here at Canonical. So that we include the application in Ubuntu, and that we keep including it. And another thing is, every half year we make a new release, every 2 years an LTS, but what is contained in a release as applications There are only applications which are as new as the feature freeze, which is 2 months before the release, before the version is released. And this means if you want to keep your operating system, you cannot get new applications. You are enjoying our support for 5 years, or you are even Ubuntu Pro member and enjoy it for 10 years, and then you have 10-year-old applications. This is not nice. And another thing, when you are an upstream maintainer, and you package the application so that all these users can have new applications, then you have to package for, say, 10 distros and more, and test on 10 distros. And I didn't consider you have to also to package for each distro when we only take the canonical supporter from Ubuntu for 4 or 5 versions of the distro. That's a nightmare, isn't it? So, and every one of you has a smartphone, and that's much easier. You have the Google Play Store or the Apple App Store, and there you have tons of applications which you can install. You do not know what is newer or older, your phone's operating system or the application, but you can just install them. And you also perhaps remember that Canonical, that they developed a smartphone operating system many years ago. They've given up on it. The community is continuing on it, but Canonical has the expertise of smartphone operating systems, and they've learned from it. And what came out of it is Snap. And what the hell are snaps? We have a method of distribution independent packaging. We have packages which one packages and tests once, and then one puts the snap into the snap store, and users of any distro can download and install it. They only need to install snapd before if the distro does not bring that. And it's Ubuntu, Debian, SUSE, Red Hat, Windows, and whatever the distro you are using. And you can use the package. And all the libraries and dependencies of the package, they are already contained. The snap contains all the dependencies of the package, so it has no external dependencies. So it does not matter which actual libraries and library versions are installed by your distro. And you get a user experience like one has with a smartphone application. And another thing, usually when you have Ubuntu and the Debian packages on it, one needs somehow trust the Debian packages. Therefore, we at Canonical are creating the Debian packages by or in general, not only Canonical, the Ubuntu community creates them. And the Ubuntu community are trusted people, and therefore we have a certain level of security. But when we want that application maintainers, upstreams, can upload their applications into our Snap Store, into our repositories, where our users can or any distributions users can easily, quickly download them, then we need more security. And this is also given by the snaps. They are because the snaps have an encapsulation, so the operating system is protected against what the snapped application is doing. We use for that App Armor, we use seccomp, and we use also namespaces. And so the application is in a sandbox. One calls it sandbox packaging, and so the operating system is protected against it. And this is the same what also happens on smartphones. And the communication to the outside we only need, and this is done through well-defined interfaces. When I show you how to snap, I show you also what interfaces are there, and that you have to use them so that your application can communicate with the system. And the Snap Store and their interfaces, which are not very dangerous, these interfaces you can use, and on installation of your application, it gets connected automatically, no problem. But there are some dangerous interfaces, and there the Snap Store has the control which of these interfaces get connected automatically when the user installs it. So we have a nice sophisticated security concept around it. And so this way we can trust third-party apps. We can allow upstream developers or independent snappers to upload something into the Snap Store without needing someone doing a sophisticated security and analysis, or without being a person who got trusted by the Ubuntu community and /or canonical. So we are not dependent anymore on the distribution maintainers for secure packages. So, and also, you know probably many other sandbox packaging systems which are created with very, very similar intentions as Snap. And you know probably one system which is the favorite system of the typical attendee of Guadec. And so, but Snap has one very important difference. Don't fear the daemons, we snap them too. We can also snap system applications, daemons, not only desktop applications. And with all this, packaging moves from distros to upstream. As we can, when we have more than 10 distros, each packaging XXX, the distros would invent the wheel 10 times. And so let upstream xxx.org snap it, and the distros take the snap. So this work goes away for the distros. And so the distro developers concentrate on the distro core, or they also contribute to the upstream code. And I think I've read some time ago that, for example, Red Hat has given up to package something as RPM package because it also exists as Flatpak, and so they did not need to package it themselves. And I hope that this had not made Red Hat firing someone, but putting the person to do something more important. And so, and what we have, we you know, immutable distributions where the operating system core is one immutable, non-changeable file system, which in case of update is completely replaced. Snap or any other sandbox packaging methods, they are immutable applications, as there we have also some immutable file system, which is in the Snap capsule in the sandbox, plus some file system naturally for the application's dynamic data. And so we have also an immutable application. And as we can snap system components, an immutable distribution based on Snap as Ubuntu Core or Ubuntu Core Desktop, there we can exchange system components. One example, for example, is the printing stack. It comes from the cup Snap, and so it's exchangeable. But we can even exchange the kernel. For example, the user can replace the original kernel by a gaming-oriented kernel. We have also a desktop session Snap, which one can also exchange by another one, so KDE instead of GNOME or so. And so we have a nicely modular, immutable application with snaps. But snaps are also a great thing to use on classically installed Linux. So let us come to the work, to our work, to learning snapping. So the first example is the hello world. And here, what we will do is we take a tiny GTK application, which is the Hello World application. It's an example which you find on the upstream website of GTK. It's a simple C program with a GUI, and I give you a step-by-step process creating the snapcraft.yaml. And snapcraft.yaml, this is a file, an instruction file, which describes how the snap is built, which components, how they are built, what in the component, what in all of this are the executables which have to be executed to use the application, and also the metadata, the name of the application, the description, the version number, and things like that. Anyone who is familiar with StarCraft, Warcraft, Charmcraft, they are very, very similar. Some things are, with some things you will be familiar, for example, with the methods how the upstream code gets loaded. So the concepts, we will have basic metadata in the snapcraft.yaml. We will have apps, which are the executables and how to run them, and which are parts, which are the upstream pieces of code and how they are downloaded and built. And I will show how to include build dependencies and runtime dependencies. And there are also plugin. These are build methods. For example, configure, make, install, auto tools, or simple make, file make, or dump. Simply copy the file and do not build anything, and so on. And we also work with local source. So if you are upstream and you have your GitHub repository with a source in it, you can also put your snapcraft.yaml into the same GitHub repository. So the source is local and does not need to be downloaded. And also manual building. One can override the standard build methods if one needs to customize them, or if one wants to work with an unsupported build method. And naturally also to build and test your work. Never upload something which you have never tested. So at first you download this link, you take your copy of the slides so that you can click the link and go to the site. And so you can download the example C file, hello world gtk.c from there. And you put it somewhere on your system. It does not need to be that path. This path I've only written because when you were using my virtual machine, you would find it there and do not need to download it. And you go to the directory, wherever you have put it, and you copy and paste this command line and press return, and it gets compiled. And after that, you execute it, and you should get something on your screen which looks like the window here, visible here. And so you know what you are snapping. And so let us build the snap. So everyone has downloaded the file. Which version of Ubuntu is that? Jammy. Yeah. Then it must be the correct one. Because this workshop, the original came from the time when we were at Jammy. And I hope now that this example app did not change, that it's not too new. Okay. Any one of you is actually succeeding to compile this application?
I succeeded, but on Mantic. So.
On what?
On Mantic.
On Mantic. Because perhaps we need Mantic now then the application has, GTK has perhaps changed, and then the application has naturally changed the same way and is too new for Jammy. What? Works also on Luna? Yeah. Yes, Luna is also newer than Jammy. Anyone succeeded to compile it on Jammy? But probably here, who comes to a Snap workshop and is therefore involved in development, probably these people typically are installing also, updating also to the small releases and not only staying with LTSs. Anyone succeeded on Jammy? So now let us go to the next step and try to snap it. And what we do now here, so we have a source code. We know that one can compile it into a binary. And now we want to create a snap. And once you have tested your binary file, this binary file easily will not work when it is snapped, because the snap is bringing its own operating system environment. It is running under the last LTS. It is Ubuntu 22.04, Jammy Jellyfish. And so the snap, when it starts, it creates an environment with this operating system. And for this, there's another snap called the core snap, which contains all the common files of Ubuntu 22.04. This is the core 22 snap. There are other core snaps for older LTSs, but I recommend always use the current one. And also this helps for the Ubuntu core desktop users that their disk does not blow up with many different core snaps. Because when we are all use the same, then one core snap helps for all the snaps which are installed. And so what we have to do is to create a snapcraft.yaml file. And at first, one thing is, so to avoid that you get an executable file into your snap, which does not work with Ubuntu 22.04, you remove your executable, which you have created by the first exercise. But don't remove the source file. This one we need. And so we create a snapcraft YAML. We create simply in the same directory where we have the source file. And this snapcraft YAML will have a metadata section in the beginning, an apps section, and a parts section. So at first, copy from the slides the metadata section. It's this one. You have a name, a version number, a summary. This is a short description in one line. A description, a longer description, which can be in several lines. And you have, as I told, the core snap, and you choose core 22. And a confinement. Confinement strict means that the snap is actually, which you get, is actually confined as I described it. You can also give another confinement. I don't know, and I don't remember exactly how it is called because I never use it. I think it's development or devel or so, where all the confinement is deactivated, which is then more for testing. But in the end, before you can put something into the Snap Store, you always have to put confinement strict. So, and there is also documentation on snapcraft.io. And I'm putting links onto my slides and at several points that you know where there's documentation about the part I'm talking about. So, and the next part which we add to the file is to copy this one. This is the apps part. It tells that we want to start /src/hello work GTK, and that this one is under the name Hello World GTK, so that when you have more than one app in one snap, that you have a name with which you can select which application you want to start. And there is the section plugs, which are interfaces. And I give the interface X11 and Wayland. These are the interfaces to the display system. And as we don't know, in some distributions we have X11, and others we have Wayland. And also we can switch in many distributions. For example, in Ubuntu we can switch. We have also a situation that some desktops use X11, some Wayland, and I think it's X11 when you have an NVIDIA graphics card. So we need access to both, and so we mention both here. With this, the application which is encapsulated can communicate with the display system. So the interfaces define all the communication methods and channels to the display system and open the AppArmor and seccomp and namespace capsule so that the application can access the display system. And now, another important part, the parts. And the parts, each part is one upstream source, which is included in the snap. In our case, we have only one, and we call it Hello World GTK. We can give it any name. We simply now use the name of the program. We use the plugin dump, which means we do not apply any standard build method. We simply copy the files of the directory in which the snapcraft.yaml is. And this is our source file, our C file. And so as we want to compile, and we compile by directly calling the compiler, which is not a supported build method of Snap. We have no plugin for it. Therefore, we use dump to simply have the file, and we simply do an override build so that we define by ourselves how we build. And this means we write a shell script. We end the override build line with a pipe symbol, which means after the line, we have a multi-line string, which is assigned to override build. And this multi-line string for override build, the expected multi-line string is a shell script. And so we write a shell script, which does the compilation. And the CD source and CD back, it depends on how you lay out your source directory. If the source and the snapcraft, yes. What?
If we had a make file, could we use it in the source script?
Yes, we can use it. This is even a standard method, so we can use the plugin make, and then it automatically uses the make file. And we have also a possibility then to give a parameter in which we list the command line options for make if we need them. And then And you see the craftctl default as the last line of the shell script. This line can be put at any place in the shell script, and when this line is executed, the default method is executed. This means if you use some standard method like auto tools, configure, make, install, you can add your own code, your own shell script code before or after the standard procedure, depending on where you put the craftctl default line. And if you have completely your own method, you can even leave the craftctl default line out, and then no standard action is done. And the next thing, the build packages. These are the packages which are required that we can build our snap, or that we can build this part. And to build this part, we need pkg-conf. This is the script which is called embedded in the command line to find out the command line options for GCC to compile code with GTK4. And we need naturally also the headers of libgtk4. So we also include libgtk4 dev. And the packages which then get installed are also the packages of the version of our core distribution. We are core 22, it's 22.04. So these packages are the Debian packages for Ubuntu 22.04. And if we had core 18 in the header, then we would install the packages for Ubuntu 18.04. Why I'm using this one. So then there are the stage packages. These are the one-time dependencies. This only works if we have the GTK library available. And we cannot use the GTK library of the user system. It can be it's once outside our capsule, not visible for us. And otherwise, it can be any version. So we do a stage package, libgtk for one. This is the binary of the library, which we need, so that this gets included in the snap. And so the executable, our compiled executable, will use that library and will work. Yes, this is the snapgraph.yaml. And now we are complete with it. We can build a snap. And for building a snap, we use the snapgraph utility with a parameter, with a command pack, which means make a package. We have now pack and not as in former time snap, as snapcraft is one of the starcraft utilities. And we want to have everything as equal as possible between them. And so we have rockcraft pack, snapcraft pack, charmcraft pack. And so we cannot use snap here as it was in former times. And as we have snapcraft, our result will be a snap. And we give some parameters for convenience. We say -v, which gives us a verbose output, so we can really see the output of configure, make, and so on. And we say --debug, which means when the build process fails, the container in which the build happens, it's an LXD container, is not left. We are left in the shell of the container, and so we can investigate the file system in which the build has happened and failed. And if we are done investigating, we simply type exit to leave that shell and the container is closed. And here you see example output, how it could look like when you are running snapcraft.yaml, the snapcraft utility, snapcraft pack. And so I want to ask you, You have copied together the snapcraft.yaml. I want to ask you to run this command and to see how it is building the snap. It can take in one step in the beginning, perhaps something like 2 minutes, because it is building the container in which the actual build happens. The build is not happening on the real iron of your computer, because the build happens under the same system under which the snap is executed. So in our case, under Ubuntu 22.04. And so it downloads an image of Ubuntu 22.04, not a big one, not the desktop, it's a small one. Mounts and opens this as a container, so runs this operating system as a container. And in this container, it runs the build process. So it mounts or copies all needed file system into it and runs the build process under Ubuntu 22.04. Independent which operating system you have actually on your computer.
I mean, how should I like build a Qt 6 application?
Which application?
Applications use Qt.
Yeah.
Qt 6.
Yes. We come later. I don't need it. Yes. It is the case. We are building GTK applications in this workshop. It was asked how to build Qt applications, but it is very similar. We will talk later on about a snap which contains all GNOME libraries. There's also a snap which contains all Qt and KDE libraries. And so anyone who wants to snap KDE applications, they can do it the same way with the appropriate snaps.
That KDE snap only contains like Qt 5 libraries, not 6.
Now we are in another situation. We have a KDE snap which contains only Qt 5. And now he wants to build a snap with Qt 6. In this case, the snap actually has to bring its own Qt library. And this means he needs to either put add Qt 6 as stage package, but most probably Ubuntu 22.04 is not new enough for that. And therefore, he will take the source of Qt 6 and include the source as another part and build it in that other part.
What about like the user, like the desktop integrations in that case?
Yes, the KDE snap, which contains all the KDE dependencies. It also contains everything needed for the desktop integration, so that your KDE program actually works with the desktop which the user is running. Any further questions?
I think it's like just two questions combined, because I'm not using the KDE snap to build the application because it's using Qt 6. So in that case, will there be like desktop integration problems?
Yes. When you are manually using Qt 6, this is a more difficult thing. You must try it out and see what is missing, and perhaps install even more packages. I don't know, perhaps you need something like libpipewire and whatever, and find out that everything works. The default desktop integration, it is secured by the GNOME and KDE snaps, but if you do everything manually, it can be that there's some what I'm doing. Sorry, Sam always forgetting that a mic is on me. And after someone has asked a question, I'm continuing with a mic, which I'm running here around, probably because I'm also not too used to be the speaker and the mic runner as one person. And what I want to say is that the GNOME, we are in the second exercise. We will have a GNOME snap that it contains everything needed for the correct desktop integration. And there's a KDE equivalent of that too available. But when you do everything by hand, as we do it here, there can be problems with the desktop. I think this application is simple enough that there are no problems. But if there are more sophisticated applications and you apply the desktop libraries like Qt or KDE by hand, build them from source, you must be very, very careful to see that it really nicely integrates with your desktop. So, any other questions? Yeah.
More so just a comment. So when you're building the Hello World application or whatever, the current one that exists on the GTK website doesn't work with Core 22 just because of one line of code. So like on the GTK application new line in your C code, you want to replace default flags with flags none, which is just a previous version of the code, and it should compile just fine.
So I think this you should somehow get to me in somewhere, somehow write it to me as a DM on MetaMost, so that I know it, because this is a bug in the workshop. Something's changed with the further distributions with the further releases of GTK, which is not compatible anymore with Jamie, and therefore the workshop needs to be appropriately updated, and therefore please send it to me as direct message on MetaMost or as email, so that I know it and I can update the workshop. Yes. Anyone else has any problem or question? Does the snap actually build?
Yeah, so you'll see application default flags. Instead of that, do application flags none, which is just what it originally was. So if you go to the Wayback Machine or whatever and see it on the GTK website, that's what it looks like previously.
Thank you. So please fix this, because otherwise your snap will not build. We have a 2 new GTK on this website, which I have referenced. The original workshop was exactly 1 year ago. And it will be easier with the next examples, because the next examples are actual packages for Ubuntu, snap packages for Ubuntu, which are packaged by our desktop team. They are under Ubuntu. And these packages are permanently updated, as this is a part of our development work on Ubuntu Core Desktop. So the other examples should work without any problem. Anyone has finished this example?
I used the pre-built image, VM image, so with that everything worked very nicely. One issue that I'm seeing is when I did a local build of the source and launched it, it worked fine in dark mode. But when I installed the snap version and launched it, it's not honoring the desktop
yes.
thing.
Yes. This is a desktop integration problem. We have now the very simple snap, as you told, desktop integration. We have the case that the snapped version does not adopt the dark mode of the desktop when we are running in dark mode, but the unsnapped version, the directly compiled and started version without snap encapsulation, it adopts the dark mode of the desktop. This is a problem with the desktop integration when we go the very simple way of compiling something simply with the GTK library. And to get full desktop integration without you needing to reinvent the wheel to find the places where the snap is breaking the desktop integration, we should go, as I show in the next examples, that we use the GNOME snap, providing all the GNOME libraries, and this contains also everything for the desktop integration. So everyone has, Ubuntu has a nice screenshot tool. Everyone has succeeded to create the snap. One thing is, I have the exercises, including the first example, also on my GitHub. So if you download it from my GitHub, because I uploaded it there a year ago, if you snap with this version of the C source code, you will also to be able to build that snap, because this is the old code.
Hi, sorry, another question. So I think this is coming from like a kind of competition perspective, because for example, if my project is very large and it's like a C++ project takes a few hours to build, in Flatpak, I mean, you have like a C cache support. So does like Snapcraft have something like that?
Unfortunately, I do not know about that. Probably not. It would, and if not, it would be a great feature request idea, at least for when one is locally snapping for developing it. In the Snap Store, for sure, one would not use such a thing to assure that not parts of an old version make it into the Snap Store, and so a mix which does not work comes up. Yes, but if it's not supported by Snap, it would be a feature request for local development. Most of you, I hope, will have succeeded to make their first snap in their life.
So the question is, can you actually go inside that namespace after the snap is created and running? Like, can you log into that namespace?
Yes. Oh, sorry. I'm not. Yes, one thing is, when we have the snap, we can log into the sandbox. There is a special command that you call snap minus, I think it is minus shell. You must look into the main page or in snap minus help. There's a command like snap minus shell, with which you can open a shell in the sandbox of the snap, independent whether the executable of the snap is running or not. You can have, by this command, a look into the sandbox. You can execute commands inside the sandbox. By this, explore what you can access from the host system. You need to specify on this command, snap minus shell, you need to specify the snap, the name of the snap, and also the name of the app inside the snap, because each app has its own plugs, its own interfaces which it connects. And so to get the shell, which a certain application in the snap, a certain executable in the snap is seeing when it's running, you can use this snap minus shell call.
But if you modify anything, I mean, it's mutable, right? You cannot modify things or save, like if you were to modify the configuration files, for example.
Yes, you cannot modify anything of the immutable file system. You can write files in it because you have the immutable file system in a snap. It's /snap / the name of the snap /current. This is the immutable file system. It's read only. And you have /var /snap /name of the snap /count. And this is the dynamic file system where you can also write files. So let us go to the next example. So one thing is, yes, one thing I've forgotten. You have built a snap, you have also to install it. I've seen that someone has already installed it, but for everyone who does not know how it works, the command is snap install. And normally snap install installs only signed snaps from the snap store. You give a name from a snap in the snap store and it installs it, like similar to apt. But we have now a local file as our snap, which is not signed because we have just snapped it. And therefore we say -- dangerous, allowing unsigned snaps. And we specify the full file name of the snap, including the .snap in the end, to select the local file instead of anything from the snap store. And we have done so. We can run the executable either by snap run and the name of the app in the apps part, or by /snap/bin/name of the executable. So you find in /snap/bin all the executables of all the snaps on your system, also of your snap.
Snap bin path appears to be already in the environment path variable.
Yes, it's in the environment, but as far as I know, user bin, so the Debian packages have priority. But you can, in your personal.bash rc, change your path to change the priorities if you want. So now you have built your first snap, and we will go to the example 2. It's the GNOME text editor. The GNOME text editor naturally it's a part of GNOME, a basic part of GNOME, and it got actually already snapped by the king of the Ubuntu core desktop, by Ken Van Dyne. And so the snap already exists, but I will use it as an example once the original snap naturally, and also some alternatives how one can snap. And this is an actual GNOME application. The name says it already, the GNOME text editor. So it needs the GNOME libraries, and it's designed to be integrated in the desktop. Meaning, for example, that when you are running in the dark mode, that when you open the GNOME text editor, independent whether it's the classic version or the snap version, it appears in the dark mode. And to use the GNOME, and we use for that the GNOME snap, because once it contains all the libraries, we do not need to put a long list of libraries into build packages and stage packages. It contains a lot. It contains also all the stuff for desktop integration, so that the community, the communication with dbus and other things is assured, that the GNOME text editor integrates nicely in the desktop. If we want to use this GNOME snap, we would need to write a lot into our snapcraft.yaml that everything works. And therefore, there's a concept of snap extensions. And the snap extension is more or less a piece of snapcraft.yaml file, which is pasted into your snapcraft.yaml file, so that this long and awkward stuff which is needed to integrate the GNOME libraries into your snap does not get to be written into your snapcraft file, but during the build process, the extension adds these parts. So you write only into the snapcraft.yaml, into the apps section of the app, which is a GNOME app. You write extensions, colon, and a list, and the list contains only GNOME. So this is the GNOME Snapcraft extension. It adds all the GNOME GTK and desktop resources. It adds the needed plugs, X11, Wayland, desktop G settings. Here, desktop, for example. This is an interface which gives the access to the desktop that you can do integration, things like dark theme or so. And you have the G settings. This is the user configuration of GNOME. So the GNOME text editor can access and it can follow to the user settings. And then it connects the GNOME content provider snaps. Content provider snaps. I've talked about a GNOME snap. This is a so-called content provider snap. It contains files, but it does not contain apps. And these files, these are made available. They are mounted. The immutable file system of the content provider snap is mounted into the file system of your snap. And so all the GNOME libraries are available to you. And so the GNOME extension takes care that these snaps are included. And so that when you install the snap from the Snap Store, automatically the GNOME snap and any other content provider snap needed is automatically installed, like a package dependency. And this is the only form how you can have package dependencies in snaps. And then you need in your snapcraft.yaml align desktop, it's in the app section also for each executable, desktop colon and the .desktop file. The .desktop file is the file which describes a desktop application and which creates a symbol in the launcher or on the desktop where you click on to start the application. And you must have a reference where this file is in your snap, and therefore you use the line desktop colon with appropriate file name. Then you also have to create a slot. Your interfaces have plugs and slots. In the first example, you have used the plugs X11 and Wayland, and these plugs, they plug into a slot provided by the core snap to have the access to X11 or to Wayland. So the core snap has slots where the plugs of your snap plug in. But any snap can also provide slots where other snaps can plug in. And if you have a GNOME desktop application or desktop application in general, you need to create also a slot, a dbus session bus slot for the GTK application registration, as the snap of the desktop is accessing your snap through that slot. And another thing is, many desktop applications, like especially the GNOME text editor, have the functionality to print your work on paper. And for security reasons, we cannot simply let it access our CUPS daemon, which we are running, because the CUPS daemon accepts any user's jobs, any application's jobs. It even, depending on a classic installation for the first user. It allows also all administrative tasks. So the snap, when it would directly access to CUPS, it can also create CUPS queues, remove CUPS queues, and even see someone else's jobs. And if we want, as we want to have a security, the application encapsulated so that our operating system is protected against the application, we need to avoid this, and therefore the plug CUPS for printing does not have a slot in the system, in the core snap, but it only can plug into the CUPS snap, and the CUPS snap is a CUPS daemon version, which is protected in itself, which has a so-called snap mediation, and allows this way, if it is accessed by the plug CUPS, that one can only print, list printers, list jobs, but one cannot modify the print queue or see jobs which are already sent. And so this, and as we need the CUPS snap itself, even if it has the CUPS daemon, it has the command line utilities of CUPS. The CUPS daemon itself is also a content provider snap and will be automatically installed. And therefore, you must take care that when you use the CUPS snap, when you use the CUPS plug, that you also put the blob into the snapcraft.yaml to install the CUPS snap as a content provider. Unfortunately, I did not create an snap extension yet, which puts using the CUPS plug and installing the CUPS snap as a content provider automatically. This is one thing which I still have to do. And I hope I will be able to do it before we complete the first version of Ubuntu Core Desktop. And so yes, that's all. So now we see here the snapcraft.yaml of the, yes, we see the first part of the snapcraft.yaml of GNOME Control Center. It's the metadata in the beginning. So the name of the application and description and so. And we see later on, we see our definition of plugs and slots. These are all our own plugs and slots, which we define in this snap. So we can define plugs and slots. They are related to some standard interface, but some modification or an interface used with parameters. And they have a name so that we can select them in the apps section. And we have a layout directive. This is that we mount a certain part of our file system into another part of the file system inside the snap. For example, when we have a hard-coded path in the executable which we are snapping, either because we are snapping binaries or because it is too awkward to modify the path when we are compiling the source code. So we can get some fixes by mounting one location of the file system into another, and so making some resources available to the executable. For example, if the executable which we are snapping wants to access on etc cupsd.conf or generally on the etc/cups directory, but we use the binary of cups where we cannot modify the path in, then we do a layout and put var cups current etc cups we mount into /etc/cups. This is the idea of layout. And now we have the apps section. We have the GNOME text editor as the name because this is intuitive. And we have the extension GNOME. This is what I told. With this, we add to our snapcraft.yaml everything which is needed so that we have a GNOME, so that we can build a GNOME application and that we get a full desktop integration. And we have some plugs. I'm not sure whether perhaps we can remove one. I think G settings is already in the GNOME extensions. But we have other plugs. We have the plug cups. And we have, because the application prints, we have Avahe observe. This is, we can see Avahe DNSSD advertisements. So the GNOME text editor is able to see network resources. And we have home. This is very important. When we have a text editor, we naturally want to open files in our home directory and save files into our home directory. And the plug home makes the user's home directory, the home directory of the user who is running the GNOME text editor, makes this directory available, but not completely. The dot files, the configuration files, the hidden files, the dot files in the home directory are not accessible. Only the non-dot files. Yes, and now to the cups. When we go back, we have one plug here. We are defining this plug who install cups. This plug is to install the cup snap as it was a content provider snap. And the slot is what I mentioned, so that the desktop can access via Debus to our application. Yes. And now we have the apps, we have the metadata, we have the apps, and now we need the parts. And we have different versions how we can do so. Our goal is to get the binary executable of the GNOME text editor into our snap, but we only need the binary executable. We will not need all the GNOME libraries because we pulled them in by the GNOME extension. And therefore, we start with something very simple. In the parts section, we add a part named GNOME text editor with a plugin dump, which needs only copy the files, which are the source. And the source is GNOME text editor, the deb package, but a local deb package. You see, I have no download path. So for this example, you download this deb package. You find it in my GitHub. In my GitHub in the part for that example, and you take the source type deb, and the source type deb considers this Debian binary package as an archive and unarchives the contained files. So by this we get the files which are in the binary Debian package. We do, but we do not execute the maintainer scripts by that. So, and important is also that unpacking a Debian package this way will not install the Debian package's dependencies. So all non-GNOME dependencies, the ones which are not covered by the GNOME snap, we need to mention explicitly in the stage packages. So this method allows to install a binary executable. The deb package is completely binary. We don't need to compile it anymore. And so we install a binary executable. This is a possibility to, for example, install a proprietary package on Ubuntu Core. We can make a snap which extracts the files of a binary package. And within this snap, we run, for example, under Ubuntu Core Desktop. Important is that this binary with appropriate dependencies pulled in by stage packages actually runs on Ubuntu 22.04. And very important, this binary package runs only on one certain special distribution. And we need, so we must take care that it runs on Ubuntu 22.04, and we must install all the needed dependencies for it. And this is one method. You can try it out because we have in my GitHub repository a copy of that deb file. Another point is also if you make snaps of binary packages and you want to publish them on the Snap Store instead only using them on your own for your Ubuntu Core Desktop, you have to take care that you have permission to do so. You cannot put up binary package, any proprietary closed source software, if you do not have permission by the license of the software. Another possibility, and this is a nice possibility for quick and dirty snapping, is to pull in some application by the stage packages and make this application the app which the snap is providing. So in this case, you do not download any source code, any ready-made binary. So you use the nil plugin, which needs this part has no source. And the nil plugin, yes. And in the stage package, you say this part is depending on GNOME text editor. This means this part for the snap build, it only installs the GNOME text editor with all its dependencies, including GNOME libraries, into the snap. But as we are using the GNOME snap, you will probably need to delete several files to reduce the size of the snap to avoid duplicates. And in the advanced topics, there are methods how you can clean up such stuff and make the snap as small as possible. This is a quick and dirty method to make a snap of a certain application which exists in Ubuntu 22.04. I have, for example, used it to put the command line utilities of cups into a snap and use this snap for testing the cups and cups control interfaces, whether they give the correct access and deny the correct access, so that I could quickly get an application which prints for testing. And now, let us go to the right way. What we should always do, if we can do it, is to compile the source. We get the newest version. We assure that the source is actually running because it's compiled for our environment. And we have the possibility to patch it, for example, if something goes wrong, and so on. Any one of you has tried out the two methods or one of them to make a snap based on a binary source? Or anyone has run into problems with this example? You don't, the deb file, for the example with the deb file, you do not need to find on Launchpad. It can be a little bit difficult to find it, depending on how familiar you are with Launchpad. It is also in my GitHub, example GitHub, so that you can easily take it from there. Perhaps there are two repositories. Perhaps the deb file is only in the repository of the completed exercises. If there are two, if there's only one, it should be in the one. Did I put a link perhaps? Perhaps then simply skip to the stage package example. Should I go on with the original? Compiling from source? Yes, as one part, as the third part of this example, we have the original version, which is where GNOME text editor gets compiled from source. There we take the official source code from the official GitLab repository. And important that we take it from GitLab repository and select the correct source version with the source tag. Is that this way we can more easily update the snaps to the next release, as there's a GitHub action available with which one can automatically update. And for this, the upstream source needs to be downloaded from Git, always with a tag to not get the newest point of development, which is usually not stable. And therefore, you should also whenever possible, not use release tarballs, but download from Git, because I will later give you also a link that you can see the workshop about how to do automatic updates. This workshop I've given some days ago in the Ubuntu Summit of this year. So for the official, so for the source, and I think there's a link. Yes, this link here on this slide goes to a blog article by Heather Ellsworth, who has written the GitHub action for automatic updating. So you can even see it there. And we use a Snapcraft plugin now to initiate the actual build from the source. And as we have a GNOME application, GNOME standard for build methods is Meson. And therefore we have to use the Meson plugin, and we have to pass parameters to the Meson build command. And the parameters for our use is prefix is user, and build type is release. The prefix is to make the build using directories like user bin, user lib, and not user local bin, user local lib. And the build type is, because probably there are other build types, for example, for debugging or so, which make much bigger executables. And for release, it's optimized simply to get used. And for the upstream version number, the snap should ideally have the same version number as the upstream package. And if you want, you can add some package release number, as we know it from Debian packages. But it should principally be the upstream release number, and to not have every time by hand to update the version number in the metadata. And especially if we later on apply automation, update automation on releases, we want to have the snaps version number always be correct. And therefore, we delegate the supply of the version number to the GNOME text editor part, and do not have it hard-coded in the metadata section. And here we tell me with the adopt info in the metadata section, which of the parts provides the version number. And and we can even other metadata let get provided by the part, for example, the description or so. And so we say we adopt info GNOME text editor, and so all the missing metadata is provided by this part. And so in the part, we put things like parse info and an XML file, the upstream or common ID in the upstream file, and so on. We in the upstream file, which comes with all GNOME applications, it's an XML file. There's all the metadata of that application, and so we can overtake it instead of hard coding it in the metadata. And important, we can also get the version number. And to overtake the version number from something in the source code, you do in the GNOME text editor part. And it must be in some override pull or override build. You add craftctl set version equals to something, and the something is something which is extracting this version number from the source code. And don't forget to have the craftctl default also in your override pull or override build. And in override pull, it must be before the craftctl snap version, set version, because the craftctl set version needs the source code already downloaded, because it finds it in the source code, and therefore the craftctl default, which does the actual default download, must be first. And if you do it in snapcraft if you do it in the override build section, it is more or less it can be more or less anywhere before or after craftctl default, because the source code is already there. And then it's important that the icons are available, so that we have an icon for the launcher. And therefore, you must put the icon into the snap, and you must refer to it with the icon equals name in the desktop file. And naturally, you must refer to the desktop file in snapcraft.yaml, as I showed earlier. So, and you build the snap the usual way. And very important, if you want to try the snap GNOME text editor, make sure that the normal classically installed text editor is not running. Close or kill it before you try the snapped GNOME text editor. Otherwise, the snapped GNOME text editor will only tell the classic editor Here we need another editor, and then the classic editor opens another tab, and the snap text editor will close again, and then you are testing around in the classic snap editor, which you do not want here. So now you have the possibility to copy and paste together the snapcraft.yaml to build the GNOME text editor from source. And one thing is, if you want to run them and try them out, it's easiest to use the command line. If you use the graphical user interface, if, for example, if you search them via the activities button in the upper left corner of your desktop, there appear two. And these two, when they are the unsnapped and the snapped version, one is the snapped version, and this is the second one.
I have an unrelated question. Debian packages have the ability to produce multiple binary packages from one source. Is there also an ability by Snap that you can create multiple Snap packages?
No. Each snapcraft.yaml produces exactly one snap file.
So I would need to basically binary copy, build binaries into the Snap package to have multiple Snapcraft packages from one source.
What you want to exactly do? You have one upstream source, and you want to have several snaps for each application in that upstream source.
Correct.
What you have to do a snapcraft YAML for each application. They all take the same upstream source, but in the apps, they select another application of this upstream project. And the other applications of that upstream project in each snap, you do not install. You can control this by the prime section where it is described what you want to install and what not. You can exclude some, or you do an override build and do not simply start make, but you cd in the directory of the desired application and only do make there. Things like that. And then each snap has only one application of that project. But you make one snap per application. If you want the possibility to install only one application. The other possibility is you make one snap. One can install this snap or not. You can install the whole project or not. And you can access all the binaries, all the executables from the project by putting more than one entry into the apps section, one for each executable. If you, for example, look into the cup snap, you have one entry in the app section, which is the cups daemon, one item which is cups browsd, one item which is LP, one item which is LP stat, one item which is LP admin, and so forth.
I'm just asking a book because I'm part of the toolchain squad, and we have applications which take hours to build. And so it's not really suitable or really resource wasteful if we build for every
then you
part.
need the first form. You take an upstream source code and do not build it completely. For example, you build only the part of it by not running make, either by when the upstream is very well organized. You have parameters for the configure script where you can tell to compile or not to compile certain parts of the project. And if it's not the case, you can also do, for example, the parts of a larger project are usually in subdirectories. So you do not simply say make, you cd in the directory for the common part, which is used by everything, do make, go back, cd in the directory of the first application which you want to include, do make, go back, and so forth, I do it this way in some printer driver snaps, printer application snaps, to only compile selected parts of an application. And this you do all in the override build. And then very important, no craft CTL default inside, because otherwise after your selected build has taken place, it would run make again, but the general make, and then it builds everything which was not built yet, and then you take the hours which you do not want to have taken. So it seems that that we will get some great snappers here, because it seems not to be that difficult.
So my question is it possible to create a snap with Python-driven scripts? So, for example, we are using the Autotask framework, and it's using the Python 2 or Python 3. We would like to make a snap. So, but the Autotask framework itself, we are not installing it. We are using the Python to executable to run the framework tool. So we would like to know if it's possible to create a snap like this.
It is, you want to snap something which uses Python scripts only for the build process.
So for the what process? Sorry.
For what process? For the build process.
Oh, for the build
So
process. Okay.
yes, so you have Python scripts in your upstream project.
Yes.
And these Python scripts are only executed while you are building your software, or are they also executed by the user?
Also executed by the user. So I
Yes,
guess I will
yes.
need to snap the Python
Yes, yes.
along with it.
Yes, Python is generally supported by Snap. There is a Snap plugin for Python. So you need you take a part. When you have a Python source code,
Yeah.
you create a path with a Python
The version,
plugin,
yeah.
and so you can install a Python project into, I do not say build or compile, because Python is an interpreter language. You can install a Python project into your Snap this way.
Oh, okay.
Yes. And if you have a mixed project where there are Python scripts inside, it's not a pure Python project, but also C, it uses probably some of the standard build methods like Meson or CMake or AutoTools. Then you use the plugin for that method. But as you have also Python inside, you need to run this build. You will need that Python is there, and when these Python scripts get even installed and run also while using it, then you need the Python also built into the Snap, and so you use the build packages or the stage packages or both, and specify a Python package, a Python interpreter there, so that your build system or your Snap, when it's ready, is capable of executing Python scripts.
Oh, okay. One another question is that, yeah, I noticed Python 3 is supported. But the problem is some module we are using are not in a preloaded Snap. So how do we work on
Yes, you have Python libraries which are perhaps not in Ubuntu 22.04. In this case, you need to add a part so that you can download this project from source, from the original maintainers, with the help of the Python plugin, so that you install this project into your Snap, and so the other parts can use it. And you can, inside a part, make a specification after, so that a certain part is only built after another part was installed.
Oh.
So your main application, you put then after Python library,
Uh-huh.
and Python library is the part which loads the Python library which the main application needs.
Oh, okay. I could give it a try. Thank you very much.
So anyone has completed this example? Anyone has a GNOME text editor which looks as nice as the original which my colleague Ken Van Dyne has created? Or the Snap created. Ken Van Dyne did not write the GNOME's text editor. Or is someone completely confused? So for everyone who is now bored because he has an extra GNOME text editor lying around and would like to snap something else, we have a third example, the GNOME calculator. It's also a standard GNOME. It's also a standard GNOME application. So it got snapped, and the snap is available also as a GNOME text editor in the Ubuntu organization on GitHub, because it's also snapped by our desktop team. I don't know who has initially snapped it, probably also Ken, but perhaps Heather, I don't know, someone of our snap squad. And you can go to GitHub to find this project, following the link. And most is the same thing as we have in the GNOME text editor. It's both GNOME applications, and these are small GNOME applications. But this time we have the summary and the description static and only pull the version out of the source code. One can do any combination. What is in the metadata statically defined is used, and what is missing is taken from the application which is under, from the part which is under adopt info. Yes, and one thing to make it easier for you, the GNOME calculator has no functionality to print your calculations or the results of them. And therefore, you do not need to include, you do not need to plug cups, and you do not need to install cups as a content provider. And now, to help to overcome the case that the source code is originally designed for classic installation, and inside a snap capsule, everything is in another directory. In the first example, in the second example, I have shown that one can fix this by layout. But one can also do another thing. When we call Meson with another prefix, and as the prefix we use where the GNOME calculator exactly lands in the snap. So we say prefix is /snap/GNOME calculator /current /user, and this is the place where when we are running the snap and the immutable file system of the snap is mounted, this is the place where the GNOME calculator gets actually installed. And in addition, some files, when we do the snap build, will fall into a wrong place and not getting found. And when we build a part, we can put an organize in this. And with this, we can move files or directories to another place inside the snap. And in the override build, we patch out the part of the build process which builds the documentation. As documentation does not make sense in a snap, the user does not see this documentation. The documentation would be somewhere in the immutable file system, and the users do not find it there. So we do simply with sed or Perl a little modification on the Meson scripts to make the build of the documentation not happen, but taking care that everything else which makes the GNOME calculator actually work will be included. And we have what I mentioned earlier with the binary, with a state package method of getting a certain binary into the snap. We have often files which we do not want in our snap, and we must clean them out. And so we have a cleanup part in GNOME calculator, which is searching the snap, which is run after everything else. See the after again. And it is searching for duplicate files, which are both in the core, which are both already in the core snap or in the GNOME content provider snap, and also in our snap, caused by our build, caused by any stage packages we have mentioned, and simply deletes these extra files from our snap so that we save disk space. For details of cleaning, see the advanced topic in the end of the slide deck. In the very end, the last section of the advanced topic are methods to clean out unneeded files. And any one of you who knows a utility named Chisel, this is another method. I've not mentioned it, but that method also works. So you can now, we are now at the end of the examples. You can now, once you can build study the Snapcraft YAML of the GNOME calculator, and if you want, build it. And another thing, if you have already an idea what you want to snap and have questions about that, some have already asked such questions, to know about how you could proceed to snap such a thing, please ask your questions. And also, I have added to the slide deck a lot of links. Once, naturally, to all the examples, and also to other snap workshops and examples of other snap workshops. For example, my very first snap workshop, which I have produced and given, is the Daemon Snappers workshop. I've mentioned it in the beginning. Don't fear the daemons, we snap them too. And because of this special feature of Snap, I have decided, and because I've made use of it, because I've snapped cups and I've snapped printer applications. These are all daemons. IPP over USB I've snapped too. These are all daemons. And these make up the printing stack of Ubuntu Core Desktop. And therefore, that I gained experience in snapping daemons, I've given a year ago the Daemon Snappers workshop in the Snap series, which I have organized. This workshop, the Daemon Snappers workshop, if you are interested in attending it, in learning how to snap system utilities, because as many of you are not in the desktop team, you are probably in some server area of Canonical, or you are in the kernel, in the server, or in the foundations team, then you are perhaps more interested in snapping daemons, and then I could make use of the rest of the engineering sprint to give a second workshop, and this would be the Daemon Snappers workshop. Is anyone interested? No one? Or would you prefer that I give the snap update automation, which is the one which I've given 2 days ago on the summit? No one? Now then I come to the links. You can every time come to me. I'm also in the desktop team, so I'm in the desktop room. If you have any wishes or questions, or also invitations to conferences where you want me to give a snap workshop. So So the next is here, there was also a workshop, an advanced workshop of desktop applications. And this was given by Olivier Tilloy. He was in the desktop team and was packaging Debian and Snap browsers. And he had also done a year ago in the workshop series Snap workshop. He worked without slide deck. He only showed examples. And the examples you can find by the link. And this is very special. Each commit of that example is one step of creating the snapgraph.yaml. So you can go into this example and then go from commit to commit, see the commit, the diffs of the commit, what got added, and so see how the snapgraph.yaml is created. And if you want to snap KDE and Qt, there is also from Jesus Soto, I think Jesus is here, a talk, yes, here, a talk he has given on the Academy about snapping Qt and KDE applications. And on the slide deck of this talk, you can also find out which content providers and so on, and whatever you need to know to snap a KDE or Qt app. And KDE is very good in snapping. KDE has their own organization on the Snap Store, I think simply KDE. And so they are really actually snapping their stuff. This is a very good idea. So you perhaps find the snap you need. And also they are also very welcome if you join and help snapping. So another thing is the auto update. I can give a workshop about that. There is a blog about it so that you can read about it, how it works, and there are also instructions how to use it. And one thing is the rumor snapped applications are slower than applications classically installed. It might have been in the beginning, but many people complained about Firefox in the beginning in 22.04. And our desktop team has investigated all these problems and has fixed most of them. And about this way to fix these problems, there are 4 blogs by Oliver Smith, the product manager desktop, where he explains everything what was wrong and what was improved. And Ubuntu Core Desktop, naturally. The link is the blog of Oliver Smith, where he mentioned Ubuntu Core Desktop for the first time and where he's comparing the different immutable distributions which are already around and explaining how each of them works so that you can get an overview of immutable distros. And if you like leaning back, watching a nice movie, you can also get something very snappy. We have 2 videos. One is a talk from Oliver Gravert about Snap. This talk was 1 year ago on the Ubuntu Summit. In the workshop, I will replace the link by a talk by me, which is updated and also covers Ubuntu Core Desktop, because I've organized a conference in India a month ago, and there I've given also a talk about Snap. But as you do not have the link here at hand, now you go to Ubuntu on Air, look for the opportunity open source, and look for the recording of the 2nd day. And the other video is a panel session, which was part a year ago of the Snap workshop series as an introduction. And there I had 7 people who are important with Snap. There's Heather, there's Ken, and there is Graham, there's even Gustavo and others, Sergio Svetchov. And we are talking about Snap and are answering the attendees' questions. So a lot of resources Also, open printing is snapping. And so you can also see snaps on the open printing website and in the open printing GitHub. And here, this is important. When you start snapping, you have often questions and want to learn some more tricks, which I cannot teach in 2 hours. So we have the advanced topics, and you can here browse through them and learn more stuff about Snap. And if you have any questions, here's the cleaning which I mentioned. If you have any questions about Snap so that you can fulfill your desires of what gets snapped, then you have the opportunity now, and please ask anyone. So there's no ask till podcast, so the best possibility for you is to ask now. It seems that you are completely confused. Not? So great. This was our workshop. I hope you liked it. You're welcome.